With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, in the question it is given a Young's double slit experiment, a parallel beam containing wavelengths lambda 1 4000 angstrom and lambda 2 5600 angstrom is incident at an angle phi 30 degree on a diaphragm having narrow slit at the separation small letter d is equal to 2 millimeter. The screen is placed at a distance capital letter D 40 centimeter from the slit. A mica slab of thickness T is equal to 5 millimeter is placed in front of one of the slits and whole of the apparatus is submerged in water. If the center bright fringe is observed at C, determine first one the refractive index of the slab, that is the mica, and second one the distance of the first black line from C. And it is given that both wavelengths are in air, so we have to consider the wavelength are in air, but the whole apparatus is submerged in water. So we have to take mu w, that is for water, is 4 divided by 3. So that is the constant value. And the diagram is given, that is Young's double slit experiment is submerged in the whole apparatus is submerged in the water, and at point S1 is the slit 1 and S2 is the slit 2, and small letter d is the distance between the slits and capital letter D is the distance between slit and screen, and point C is the point where central bright fringe is observed, and phi is the angle, incident angle. So we need to calculate, first we need to calculate the refractive index of the slab. That is, let us assume that one mica sheet is kept at the slit 2. So if we are placing one mica slab of thickness T is equal to 5 millimeter. In the question itself they have mentioned that mica sheet is kept at any of these two slits. So I am considering at slit 2. So what happened is there will be some normal line here. So this is the distance. So consider it as delta x, and this is the d. So since this angle is 5, this angle must be 5. So how to calculate the angle phi? Using sine theta equation, that is opposite by adjacent. That is sine phi is equal to opposite is delta x, adjacent is d. So we need to suppose we need to calculate delta x means d sine phi. So path difference of slit. So now we have the equation for path difference of the slit, delta x is equal to d into sine phi. So when we place a mica sheet in slit, so the path difference of mica sheet will be, so this consider it as delta x1 for mica sheet. The path difference will be, that is mu m for water minus 1 into thickness of the mica sheet. So when these path difference become equal, we can observe the bright fringe at the center point C. So we can only observe the bright fringe at point C if these path difference, that is path difference of the slit and path difference of the mica sheet becomes equal. So equating these two equations, since in the question itself they have mentioned that the bright fringe is observed at the point C. So this is only happens when these two equations becomes equal. That is d sine phi must be equal to mu m of water minus 1 into t. So substituting the values, we have d small letter d So writing the equation, D is equal to 2 millimeter, that is minus 3 meter, capital letter D as 40 centimeter, that is minus 2 meter, and lambda 1 value as 4000 angstrom, and lambda 2 as 5600 angstrom, and thickness it is 5 into 10 to the power minus 3 meter. And so these are the values given. So substituting this value here in this equation, 2 into 10 to the power minus 3 into sine, and theta is given, that is phi is given 30 degree, sine 30 is equal to mu m minus 1 with respect to water. And we have the value of mu m for air, right? We don't know the value of mu m with respect to water, for water. First we need to calculate that. Into T is 5 into 10 to the power minus 3 meter. And this 2, okay, sine 30 is nothing but 1 divided by 2. This 2 and this 2 cancels. So the remaining is 10 to the power minus 3 is equal to mu m for water minus 1 into 5 into 10 to the power minus 3. And we need to calculate mu m for water, that is mu m for water minus 1 is equal to, what happens, divided by 5 into 10 to the power minus 3. So this one gets cancelled, so that answer is 1 divided by 5. So mu m for water is equal to 1 divided by 5 plus 1, that is 0.2 plus 1. So the value of mu m for water is equal to 1.2. So now we have the value for mu m. So but mu m with respect to water is this value, that is mu m with respect to water is equal to 1.2. So mu m will be, that is 1.2 into mu water, that is mu m is equal to 1.2 into, we have this value 4 divided by 3, that is 1.6. So this is the answer for question 1, that is the refractive index of the slab. Moving on to question B, that is the distance of first black line from C. So suppose the first black line is observed at this point, and the distance between C and the first line, consider it as y, and we need to calculate the distance y. So if we have two lines, then first black line on either side of C must be at the same distance. So equation to calculate y is, we know the equation to calculate y as y is equal to 2n minus 1 lambda d divided by 2d. So if we are considering two lines, right, first black line on either side of C, then those first lines are on equal distance from the C. So we need to consider two cases, and they must be equal. So from this equation we can write for first black line on upper side and first black line on lower side, that is 2n1, consider n1 first case, into lambda 1 d divided by 2d is equal to 2n2 minus 1 into lambda 2d divided by 2d. So where lambda is equal to lambda divided by mu m, because setup is kept inside the water. So 2n1 minus 1 divided by, rearranging, these two gets cancelled, dd gets cancelled. So rearranging, we will get lambda 2 divided by lambda 1. That is 2n minus 1 divided by 2n2 minus 1. Substituting the values of lambda 1 and lambda 2, 5600 divided by 4000, that is equal to 7 by 5. So we have from this equation n1 2n minus 1, 2n2 minus 1 is equal to 7 by 5. So from this equation we can easily calculate the value of n1 and n2. That is, if we substitute what value for n1, we are getting 7, that we have to check. If we substitute for n1 as 4, that means 4 into 2, that is 8, minus 1 is 7. So n1 must be 4 and n2 must be 3 to get 5 as the answer. That is 3 into 2, 6 minus 1 is 5. So n1 is equal to 4 and n2 must be 3. So y is equal to, so in this equation we are going to substitute the values. Y is equal to 2 into any value. I am here considering n1 minus 1 lambda 1 d divided by 2d, that is 2 into n1 4. Any value you can consider, either n1 or n2. If you are considering n1 here, you must consider lambda 1. If you are considering n2 here, you must consider lambda 2 here. Minus 1 into lambda 1 value is 4000 into 10 to the power 10 into d, 40 into 10 to the power minus 2. So when we are considering lambda here, lambda must be equal to, if you consider the whole setup is inside the water, so lambda is equal to lambda divided by mu m. So this entire equation must be divided by mu m, that is mu m value is 4 divided by 3. So into 3 divided by 4 into, so dividing 4 by 3, that divided by 4 into 2 into small letter d, that is 2 into 10 to the power minus 3. So this value is equal to, from calculating we will get 2.1 into 10 to the power minus 4 meter. So in standard value we can write 210 micrometer. So this is the answer for the question B. So I hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.